Hello everyone, welcome to Young Einstein. Today we'll be talking about how to sum up the terms in an arithmetic progression. How to sum up the terms in an arithmetic progression. On the previous video we did arithmetic progression, the formula for arithmetic progression, but now the terms in the arithmetic progression, how to add them up. The topic is sum of an AP, where AP means arithmetic progression. So before we get into the lesson, please make sure you subscribe, leave comments and comment on other topics you would like me to touch, and also ask questions that you're confused on. So sum of an arithmetic progression. So this topic has a historical background. A mathematician named Frederick Gauss, he was the one who provided a short way to sum up series in an arithmetic progression. To sum up the terms in arithmetic progression, he was the one who provided a short way. So this is what happened. The class teacher asked the whole class to sum up all integers from 1 to 100. That is 1 plus 2 plus 3 plus 4 plus 5 up to 100. And within seconds, Gauss delivered the answer. His answer was 5050, which is actually correct. And everybody was astounded, like how in 15, not up to 15 seconds, he could deliver the answer. So he explained the way he solved it. So if you have 1 plus 2 plus 3 plus 4 plus 5 plus 6. That is what the teacher said you should do. Up to plus 99 plus 100. If you have that, you can rearrange it in such a way that your 100 will come first. To add 1, that will be 1 plus 100 separate. 2 plus 99, 3 plus 98, 4 plus 97, 5 plus 96, 6 plus 95, and so on until you get to 49 plus 52, 50 plus 51. That's just simply rearranging all the terms together. So that's simply rearranging the terms. It's still the same terms that it contains, but he brought 1 to sum with 100, 2 to sum with 99, 3 to sum with 98. Now he grouped the 1 and 100 together, the 2 and 99 together, 3 and 98 together, and so on. Now they're into 50 groups. Now in each group, if you notice, 1 plus 100 is 101, 2 plus 99 is another 101, 3 plus 98 is another 101. In each group, the sum in each group is 101. And since it was group 2, they are into 50 groups. There were initially 100 terms, group 2. That is 100 divided by 250. And so in each group, it is 101. So we're adding 101 in 50 places. That is 101 plus 101 plus 101, which in short is 101 times 50. 101 times 50, you will get 5050. 5050. So that was how Gauss did it and got his answer. So let's see the technique that Gauss used. So when Gauss added 1 plus 100, in essence, he added the first term plus the last term. 1 was the first term and 100 is the last term. So he added 1 plus 100, meaning he added the first term plus the last term, that is A plus L. Remember from the previous video, A in arithmetic progression is the first term, while L is the last term. So he added A plus L and he got 101. Then that 101, he multiplied it by 50. That 101, he multiplied it by 50. Now how does the 50 come about? So we know there are 100 terms from 1 to 100. Now 50 is that 100 divided by 2. 50 is the 100 divided by 2. So in essence, it did n over 2. And where n is the number of terms, which is 100 in this case, divided by 2, that's 50. So he multiplied n over 2 by A plus L. N over 2, he multiplied with A plus L. So the formula which he used was n over 2 open bracket A plus L. So that is the formula for the sum of n terms in an AP. Sn is equal to n over 2 open bracket A plus L. So when they say find the sum of the first 7th term, first 8th term, that's the formula we use. So this is one formula, Sn equal to n over 2 open bracket A plus L. In this formula, n means number of terms, A means the first term, while L means the last term. N is the number of terms, A means the first term, L is the last term. So this formula is used when you have your last term. But there are some situations where you might not be given your last term, but you are given an extra information, which is the common difference. You're given extra information, which is the common difference. So in that case, to find your last term from the previous video, formula to get your last term is a plus n minus 1, a plus open bracket n minus 1 close bracket d. In this case, n is the number of terms and d is the common difference. So that's the formula to get your last term. That's L is equal to a plus open bracket n minus 1 close bracket d. Now, this formula, you can put it in the first equation, the first formula for sum of n terms, so that you have Sn is equal to n over 2 open bracket a plus open another bracket n minus 1 close bracket d, then close bracket again. So in this case, I just put the formula that we have, that L is equal to a plus n minus 1 d inside the equation 1, the first formula, and that's how I got this. Now in here that will have a plus a plus a will give you 2a. So your formula is Sn is equal to n over 2 open bracket 2a plus open bracket n minus 1 close bracket d close bracket. So that is the second formula for sum of n term. So the first formula, note this, the first formula is used when you have your last term. The second formula is used when you have your common difference. But generally, it is easier to use the first formula. But if you don't have your last term, then you better use your second formula. That is where they give you a common difference. So let's take an example. So, example 1. There are 15 terms in the AP. 9, 11, 13, and so on, up to 37. There are 15 terms in the AP. 9, 11, 13, and so on, up to 57, up to 37. It said find the sum of the AP. Find the sum of the AP. So now they're giving us that this is an AP. So what we need to do is, can we get the common difference? Can we? Yes, we can get the common difference. Common difference will be 11 minus 9, which is 2. Or you can also try 13 minus 11, which will still give you 2. But in this question, although you can get the common difference is not needed for this particular question. Why? Because we have our last term. We have to find the sum of an AP. There are two formulas for sum of an AP. One formula requires last term, another formula requires common difference. Now, since they gave us the last term is 37. After 37, they not say and so on. They stop at 37. So 37 is the last term. So since we have our last term, we can easily use the first formula. Remember I said that first formula is easier to use. So although we know our common difference as 2, we will not use the second formula because it's more hectic than the first formula. So I'm using the first formula that has the last term. The first formula is Sn is equal to n over 2 open bracket a plus l. Our a is the first term, which is 9. N is the number of terms, which is 15, and L is the last term, 37. So we have that S15. I'm talking about S15 because we're talking the sum of the 15 terms, the first 15 terms. So that I'm using S15 now, no longer use Sn. So S15 is equal to 15 over 2. The n became 15, that is 15 over 2, open bracket 9 plus 37. The a became 9 because the first term is 9. The L became 37 because the last term is 37. So what we will have inside the bracket, that 9 plus 37 will give you 46. So Sn is equal to 15 over 2, open bracket 46, close bracket. So now that 46, you can divide it by the 2. You will get 23. So Sn is equal to 15 multiplied by 23. So Sn is equal to 345. 15 times 23 is 345. So that is the sum of this AP that has 15 terms. So S15 is equal to 345. So let's take the second example. Find the sum of the first 30 terms of the series. The first 30 terms of the series. Minus 5, 2, 9, and so on. Minus 5, 2, 9, and so on. So in this question, we are not given the last term as the former question gave us. So this time around, we will get our common difference and use the second formula. But if you look at this question, we were not instructed that this is an AP. The first example clearly stated that it was an AP. But this one now, we're not giving that as an AP. So we have to determine if there is a common difference. You have to determine yourself if there is a common difference. Then you state it yourself that it is an AP because there is a common difference. So to get a common difference, you do your second term minus your first term, or you do your third term minus your second term. So we will do both of them. We will do second term minus first term, third term minus second term, and if both answers are the same, we will conclude that it is an AP. And when you conclude as an AP, that's when you use your AP formulas. If you have not concluded that it's an AP, you can't use your formulas. So this is how you solve it in exam. This carries marks in exam. So let's conclude as an AP first of all. So the second term minus the first term. Second term is 2. The first term is minus 5. So we're saying 2 minus 5. 2 minus 5. This double minus now is minus times minus, which will give you plus. So you're having 2 plus 5. 2 plus 5 is 7. So that's the difference when we use second term and first term. Let's get the difference when we use third term and second term. The third term is 9. The second term is 2. 9 minus 2 is 7. We still get 7. So since both answers are the same, we will say that this is an AP. Now that I've gotten as an AP, we're free to use the sum of terms of an AP. Now sum of terms of an AP. Now we're using our common difference formula. The formula that requires common difference. That's what we're using. So S30, because we're looking for Sn is equal to n over 2 open bracket 2a plus n minus 1 close bracket d close bracket. That's your formula. Now we're looking for S30 because they say find the sum of the first 30 terms. So S30 will be equal to 30 over 2. It's 30 over 2 because now our n is 30, that's the number of terms. 30 over 2 open bracket 2 open bracket minus 5. It's minus 5 because the first term in this AP is minus 5 plus close open bracket 30 minus 1. It's 30 minus 1 because n is 30 minus 1 close bracket 7 because d is 7. So outside that 30 over 2 part is 30 divided by 2 is 15. So S30 is equal to 15 open bracket the 2 and minus 5 together. When you multiply you get minus 10. So S30 is equal to 15 minus 10 plus 29 open bracket 7. I got 29 because when you do 30 minus 1 you get 29. Now 29 multiplied by 7 you get 203. So you have that S30 is equal to 15 open bracket minus 10 plus 203. Now minus 10 plus 203 you get 193. So S30 is equal to 15 open bracket 193 close bracket. So you're multiplying 15 by 193 and your final answer with that S30 is equal to 2,895. So that's the sum of the first 30 terms of this AP.